Okay, so in this video we're going to talk about linear functions and their slope. Okay, so say we have this coordinate plane here, a horizontal axis and a vertical axis. And let's say I ask you to help me graph or draw on this coordinate plane a line. Okay, now in math, when we talk about a line, we're talking about a straight line. Okay, so if I ask you in your head, imagine a straight line drawn on this coordinate plane somewhere. And now tell me how to draw that line on this plane. Okay, instruct me or guide me and help me to draw that exact line that you're thinking about in your head. Okay, what would you need? What would you need to tell me in order for me to construct the exact line that you're thinking about in your head? So hopefully you recognize that you would need to tell me at least 2 points that are on this line. Okay, so for example, if I give you 2 points, say the points, 3, 2, and let's say 5, 4. Okay, so this is the point 3, 2. This is the point at 5, 4. Now that I know that I want a line that goes through these exact points, then I can connect those points with a straight line that goes on forever in both directions. So imagine this is as straight as it can be. I don't have a straight edge with me, but imagine it's perfectly straight. Okay, so notice that in order to direct me or guide me to draw this exact line, I needed at least 2 points on that line so that I could connect those points. Now what if I asked you to help me draw a different line, a line that is not the same as this blue line? What would you need? So again, you would need 2 points, right? We need 2 points, connect those points to get our line. But if I want a line that's different from this line, notice I can't pick 2 points that are on this line, right? If I pick 2 other points that are on this line, say this point and this point, yes, I've picked 2 points, but because they're on this line already, when I connect them, I'll get the same line. But I want a different line. So what I need is at least 1 point that's off of this line. Okay, so for example, let's say 3, 3, and maybe 2, 2. Now if I connect these 2 lines, 2 points with a line, I get a new line. Okay, so what you should realize is a line is uniquely determined by the points on that line. Okay, so for any 2 points that you pick, there's only one line that will go through those 2 points. Okay, so now taking a look at these 2 lines here, what can we say about these 2 lines other than talking about the fact that they have different points? What else do you notice about these 2 lines? What's different about them? So some of you might be thinking, well, this one, the blue one is tilted a little bit more than the red one, or the red one is steeper than the blue one. Okay, so this notion of steepness is something that we call the slope of the line in mathematics. Okay, and the slope of the line is given to us by the variable m, and we can find that slope if we have 2 points on the line. So let's say this point on the blue line, I'm going to call it x1, y1, and let's call this point here x2, y2. Okay, so the first component we're labeling as x2 and the second component y2, and for this point x1 and y1. So now to find the slope of this blue line, we can take those 2 points, we can take the y values or the output values. Remember we said in an earlier video that the second component represents the output, the first component represents the input. So if I take the difference of my output values, y2 minus y1, and divide that by the difference of the corresponding input values, x2 minus x1, this right here gives us what we call the slope of the blue line. Okay, and you can also swap these. This will give you the same result as if you took y1 minus y2 over x1 minus x2. Okay, and oftentimes you'll hear me say the rise over the run. Okay, the slope is the rise over the run. The slope measures how fast your line is falling or rising, how quickly it's falling or rising. Okay, also the slope, you might hear me say that it represents the average rate of change of your function given by this line. Okay, so if I'm talking about this blue line in terms of a function, so let's say this blue line represents a function that we've called f of x. Then to find the slope, remember we said it's the change in the output values over the change in the input values. So this point right here, y1 is an output value, which I can also write as f of x1, right? y1 is the output value corresponding to the input value x1. So this second component can also be represented as f of x1 if this first component here is x1. Similarly, for this point here, I can write this as x2 f of x2. So that means that my slope I can write as f of x2 minus f of x1 divided by x2 minus x1. Okay, so let's take a look at an example of finding the slope if we're given 2 points on the graph. So let's say we're given the points 3, 5, and 7, 1. And let's say we want to find the average rate of change or the slope of the line that passes through these 2 points. Okay? The slope of the line passing through these 2 points is, and we can use this formula that we just discussed, m is equal to, here is my, let's label these x1 and y1. And let's label this one as x2, y2. So this then, if I want to use this guy, this is going to be 1 minus 5 over 7 minus 3. Okay, and that gives us negative 4 divided by positive 4, which simplifies to negative 1. Okay, so the slope, or the rate of change, of the line passing through these 2 points is negative 1. Okay, so let's look at another example. We're asked to find the average rate of change on the interval 0 to 3 for this graph that's given to us here. So we're given a graph. The red curve is given to us by the function f of x equals x squared. And if we're asked to find the average rate of change, remember average rate of change is the slope. And earlier I gave you the formula, let me see. that the slope, if we're talking about a function, is f of x1 minus f of x2 over x1 minus x2. But now, where do we figure out what our x1 and x2 are? So if we look in the statement here, find the average rate of change on the interval 0 to 3 for the graph. So this interval here is going to give us our x1 and x2. Okay, so if I look at my graph, at 0, I have a point on the graph here at 0, 0. And at x equals 3, I have a point on the graph at 3, comma, whatever this output value is for this input value. But how do I figure out what that output value is? That's going to be f of 3. Right? Because this red curve here is given to us by this function f of x. So if I input 3 for x, my x value here, it should give me the output value of that point for input 3. Okay, so notice here, if I fill in this formula, my x1 and x2, x1 is 0, x2 is 3. And now f of 0 is 0. You can either see that it's at the origin, or plug in 0 to your function. F of 0 equals 0 squared, which equals 0. And f of 3, let's plug in 3 to f of x. So I get 3 squared, which is 9. 0 minus 3 in the denominator, and let's simplify. 0 minus 9 is negative 9, 0 minus 3 is negative 3, and negative 9 divided by negative 3 is positive 3. So the average rate of change on the interval 0 to 3 for this graph is 3. And now we said this is the slope of a line, but what line am I talking about? That's the line that connects these 2 points here. So the average rate of change, or the slope of the line connecting those 2 points at 0, 0 and 3, 9 is 3.